So this is the task program I've been building. I'm using it for this script. The first thing I wanted to quickly outline was the structure of a task. It's got a title, done. Very few tasks are done because they tend to get deleted when they are rather than sticking around. Space for notes, space for multiple tags, optional start time, category. Every tag is part of a category. The category forms a hierarchy. And then after dependencies, I've talked about before, they function the same way, but they have a different connotation. So if we go look at the category, it's pretty simple. It has a name. Subs are the subcategories. Tasks are the tasks within that category. The next data structure it's worth looking at is the query. The query is how I actually select a set of tasks. So I can do it by category, and as this note defines, I can do either tasks immediately within a category, or I can identify a category and say all descendant tasks by prefixing it with star. There's a bunch of these ternary, which means they can be true, false, or not applicable. So whether the task is active, has a start date, whether it's done, whether it has dependencies, has requirements. And note that has dependencies means either dependencies or after, because for filtering it doesn't really matter. And then has requirements is the other direction, is this task required by something else. Then we can have start dates, and you'll see that they have the format of either year, month, day, or I can do a number followed by day, week, months, or years. So for start, the other thing that's missing here is that it requires a comparator. So either greater than, less than, greater than, equal to, less than, or equal to. Same thing with tags. Tags can be negated with an exclamation point. Other than that, it's just looking for tags. Parameters you'll see in a second, but it's a way for me to have one query that I can change by changing the parameters. And parameters right now just apply to tags and categories. The results are just returned as a category because all the category is the names, the subs, and the tasks. So when I started building it, it turned out that's what the results look like too. And so it's just this where the root is going to be empty, and it'll contain all of the categories that actually had results. Also, to make this work, categories has a merge feature where I can take two and mash them together, and that's for the results. It won't duplicate things, but it just creates a union. So this is the document where the queries are kept. I haven't really shown how the renderer works yet, but the renderer just contains options for what fields to display. And the template tells it which template the renderer needs to use. The queries are the more interesting part. The queries will all get merged together, and you'll see some of them have parameters. So taking a look at this one, the parameter is %1 for today, and it's active tag. So if we go and find active tag, %1, so it's going to look for whatever tag you give it, and it's active. So rather than needing a different query for every tag that I want to be able to search for, I just have one, and I change out the parameters. Other than that, the queries are pretty much what you would expect. So now I can show you the structure that I'm using for the actual tasks documents. They look like this. And so to define a task, there's going to be a set of brackets. They can be like this. I try not to do that. But there's typically either a space or an X to indicate it's done. Then comes the title, and then anything after that is going to be meta information. Like down here, meta information can go on successive lines. Lines that don't have any meta information are notes. And the metadata can be, this is saying do this after there's a task somewhere, breakdown composter. This one is saying do this after the task that's above. So that lets me create series like these three where it's do this, then do this, then do this. Something like this is saying after the date. So these double rights always mean after. Double left means requirement. So I can't finish the loft until after the basement order is done. Something about this task requires this task to be done. This is a tag. You can see in this line, I'm doing two different types of metadata because I can. So there's a tag, and then this comes after the floor transition strip. I can also create these meta tag groups where everything in here has this applied, and because of the way the parsing works, it doesn't care about leaving white space. That gets stripped out, which allows me to do indentations. The other important property is these are categories. Anything with two is a root category, and then as they go down, they're nested. So this is one level down from root. And in this case, I don't actually define a root in here. It takes the name of the file. So projects is going to be the root, and this is going to be projects.it, then projects.house, projects.shop. Oh, I don't have any 4 deep in here. But another useful tool is that this is a root category, but the way it ends up getting parsed is it gets split on the dot. And so this becomes the category todo.demos. And if I was to do another thing here, even though this is a 3, it's saying that it's one layer deeper than the previous one, but it would be the third layer deep, not the second that you might expect. It sounds a little confusing, but it ends up being really simple in practice, that if I want to go to a specific category and start working, I can do this. And yes, it's parsing Go files as well. So I have it pointed at a few root directories of projects that I'm actively working on, and I can now add tasks there, and they get picked up. There's the demo, task0 demo, and I can even show that it works. So now the next thing I wanted to show you was the parser, and I don't want to go into a lot of detail because the top levels of how this works are kind of interesting, but once you get into the weeds, not so much. So it's done with mostly just regular expressions, and some of them get kind of complicated, but most of these are actually pretty straightforward. So like days of the week. But all of these depend on this thing, which is part of the Lucci string library. And this is really straightforward. It's a slice of regular expressions. It's created with a slice of strings. And when you give it a string to match against, it goes through and does find string submatch against all of them. And the first one, in the order that it was defined, that matches, it returns the string of the regular expression and the match. So if we come back over here, there we go, default line parser. In here, give it a line, it runs the match, and then it goes by the ID, and I just use the regular expression strings themselves as tokens to see what they're matching against. This is how I process the meta stack, and there's another one for handling the meta data, and they're pretty much the same. If you were to compare this to this, it's either the meta stack applies it to the current meta stack, and the handle meta just applies the metadata to the current task. So this is all the core parser. The last detail that's interesting is This parser pretty much just uses the default parser straight. It parses a tasks file. This one's a Go parser, which still uses most of the core logic, but it has a little extra logic so that it searches for a comment that has a task in it and then continues reading until the end of the comment block. Another piece I wanted to show was the scanner. This is really not core to the task0 logic, but I just decided to make it part of task0 so that I didn't have to figure out how to generalize it. It was really straightforward to write exactly what I needed. And this thing scans a directory, finds the files that I care about, and then does a sort of passive watch on them. So it's looking for .tasks or .go right now. This is some logic that I wrote inside of Lucci that does exactly that. And so when you do a scan, it goes through starting at the roots and finds all of them. Hard is a Boolean that gets passed in, and scan always calls load, and hard gets passed through to there. Load goes through each file, and it does a check of if it's hard, it always rescans the file. It rereads the file, reparses the file. And then if it either hasn't scanned the file before, or the date has changed, any of these conditions cause it to do a parse of the file. This means that when I call load and hard is set to false, it will only rescan files that have changed. And those three concepts map to these three icons. This does a rescan calling load, so it just loads any files that have changed. This scans the directories and loads any new files or files that have changed. And this one actually dumps the entire repo and does a hard rescan. This is the interface. This is what serves as home. So I've got the queries that I want available most accessibly in the header, and then everything that I've defined but it's not in the menu just gets shown here. Not the best UI, but stats is actually not a query. It takes me to this stats page that shows me stats about how many tasks I have. This is the view I use most. This is the HTML view. Every task gets one line, but then I can click on something and it expands out. Very useful is it shows me which document it came from and the line number. That is one of the things that has made the system usable. I have a couple other views that I do use. This is my headers view, so this shows me things that are upcoming. Similarly, this is my daily view, and it's in JSON because I have another tool that I can just copy and paste this into. And then I'll show you, this is the view that I actually started with. I didn't add the HTML view until very recently, 2 or 3 days ago. Initially, I was just doing very plain text rendering that actually matched the format that it reads from. And that really helped with the early development so that I could move quickly